Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
You're watching Real-Time Web with Node.js. In this level, we're going to be covering Socket.io to build a chat application. So because we're building a chat application, we're going to have a bunch of different clients that need to receive messages right away. Let's say someone sends a message to the chat. We want to push that message from the server to all the clients at the same time. But in traditional HTTP, this isn't really how it works, as you can see here. What we want to be able to do is send and receive messages from the client to the server and from the server to the client at the same time. And this is exactly what WebSockets do. Fortunately, WebSockets is a pretty new technology on the client side. So we need something to abstract WebSockets and give us a good API to use on newer browsers and older browsers. And that's where Socket.io comes in. So let's start using Socket.io to build this chat application. All we have to do is first install it using npm. Inside our app, we can require Socket.io. And then after we create our Express server, we can pass in the application created by Express to the socket listen function. This will return an object that we can use to listen for connections coming from the client side. Here, all we're doing is when a new client connects to our server, we're just going to log out client connected. We need a client, which in this case is just our browser. On the client side, we also need to load the Socket.io library. Then we can connect to the server from the client, passing in our server's URL. Now, on our server, we're actually really easily able to send messages to the client. Now, this wasn't possible before with just regular HTTP. When our client connects, we can start emitting events on that client, such as submitting a messages event and passing in this data. To receive this event on the client side, all we have to do is listen on the messages event and pass in a callback. And that callback will have the data emitted from the server. Here, all we're doing is alerting that data to the browser. So let's see this in action. Let's fire up our Node app and go over to the browser and load up our site. So you can see when the client connects to the server, it's going to alert the data that came back from the server. And we're also going to see in the log that our client connected. Just like we sent a message from the server to the client, we can also do the same thing from the client to the server. First, on our server, let's set up a listener on the messages event to log data whenever the client sends the messages event. Over on our client, we're going to use jQuery to hook into our chat form. And whenever that's submitted, we're going to take the value out of the chat input, which is our text box, and we're going to emit that messages event on the server. Let's see that in action. Again, let's fire up our Node app and go over to the browser, connect to localhost 8080. As you can see, the client connected successfully. And when we type a message and submit the form, it will emit the messages event on the server. As you can see here, the data is being printed out to the console. Pretty cool. The really powerful thing about Socket.io, as opposed to just regular WebSockets, is that it makes it really easy to do something else other than one-to-one communication. Let's say you have a client sends a message to the server, and you want to broadcast that message out to all the other clients. Well, Socket.io gives us the broadcast flag for that. Let's use the broadcast functionality in our chat app to, instead of just logging the message to the server, let's broadcast that message out to all the other clients. The only thing that we need to do on our client now is listen for messages events, and when we get one of those events, we insert the message into our chat app. Once again, we're over in the terminal, and we're going to fire up our Node app And now we're going to connect with two different clients so we can see this broadcast functionality at work. So we connect with our first client and we see that it has connected successfully. Then we open up another browser and connect with that client, and we can see that now we have two clients connected. So when one of those clients types in a message and hits enter, it's going to broadcast out that message to the other client. Pretty fantastic. As we saw in that last screencast, now that we're broadcasting messages around between clients, we might actually want to attach a name to that message so we know who's sending it. So how do we do that in Socket.io? Let's go back to our server, and we're going to listen on a custom event called join. Now when our client emits that event, it's going to pass in the name of the user. So we have our name in the callback. All we need to do is call set on the client to define that client's nickname. We'll see how to use that later when broadcasting messages. But for now, let's check out the client. We're going to add code to listen for the connect event. And when that happens, we're going to prompt the user for their nickname. After they enter their nickname, we're going to then emit the join event on the server, passing it in. Back on our server, now before we send out a new message to all the other clients, we have to use client.get. We pass in the property that we want to get, and we give it a callback, which will include the name that we previously set on the client. So now when we broadcast out that message to all the other clients, we can pass the name and the message to identify the client. Let's see it in action. Just like before, we fire up our node server, we connect with our first client, and now we're actually going to ask the user for their nickname when they first connect, as you can see here. So dog is the first user. Our second client is named Spider. So now when Spider sends a message to the dog sees that Spider is the one sending the message, as you can see here. So we're done with level 6, but we're going to continue on in level 7 on building this chat application. But for now, go into the challenges and practice using Socket.io.